Number 19, let's change the order of integration in this double integral. Looks like we're going to have to write it as the sum of two iterated integrals. Okay, before we do anything else, we want to draw a picture here. And even before we draw the picture, I guess we need to fill in what are the bounds. X runs from 1 to 8. Y runs from 24 over x to 25 minus x. Okay, so what does this look like? X runs from, so there's 1, there's 8, there's those bounds here. Y is 25 minus x. Okay, so there's y is equal to 25 minus x. And then the curve 24, let's figure out before we do anything else where are some points of intersection right now. When x is 1, y is 24. So this is the point 1, comma 24. When x is 8, y is 17. 25 minus 8 is 17. Because then the curve y is equal to 24 over x. When x is 1, y is 24 over 1 is 24. So we also go through this point right here. So this is the curve y is equal to 24 over x. And then when x is 8, y is 24 over 8 is 3. So okay, this is the region here. So x runs from 1 to 8. For a particular value x, y runs from the curve y is equal to 24 over x to y is equal to 25 minus x. So now we're being asked to reverse the order of integration here. How do we do that? Okay, so the thing to realize here is that we're going to want to take this area. We're going to take this area and slice it horizontally instead of slicing it vertically. So we're going to be thinking of right function and left function instead of top and bottom here. Realize that the right function changes when y is 17. So above, so this is the point x is 8, y is 17. So this is y is equal to 17 right here. Above y is equal to 17, we have bounds, these bounds. Below y is 17, the right bound changes to this from this. Okay, so this is the setup. Now we just need to fill in the details here. So let me just get all of this stuff set up, written down here. So this will be the top part. This will be the bottom part. For the top part, y runs from 17 to 24. And for the bottom part, y runs from 3 to 17. For the top part, the left function, the smaller, the lower bound on x. So again, it's kind of like for a particular value of y, x runs from here to here. This is a smaller value of x. So this curve is y is equal to 24 over x. Solving x in terms of y, x is 24 over y. So that's the lower bound here, x in terms of y. The upper bound for this one will be this line, y is equal to 25 minus x. Again, solve for x in terms of y, and you'd end up with x is equal to 25 minus y. And so these bounds represent this top region. For the bottom region down here, the smallest x can be, again for like this particular value of y, we run from here to here, smallest x can be is 24 over y, and the biggest x can be is x is equal to 8. So these are the bounds that we need to use to fill in to write down our final answer. So what is our final answer? So the first integral for the top part, y runs from 17 to 24. X runs from 24 over y to 25 minus y. F of xy, we aren't changing the integrand. We don't change integrand when we change the order of the integrals. Dx, dy, we do change the order. This was dy, dx. Now it's dx, dy. Plus the second integral, y runs from 3 to 17. X runs from 24 over y to 8. F of xy, dx, dy. So here's our final answer. It's going to be very difficult to do this problem without drawing the picture. So that's my big advice here, is draw the picture.